Hello everyone and welcome back to my channel. Today we will be discussing gas laws. Today our effort will be shifted to the students, undergraduate students, students that are writing WAEC, students that are writing JAMB. We want them to understand gas laws, understand it fully, and how to perform some calculations in gas laws. So today we will discuss Boyle's law, Charles' law, and the general gas law. So we'll start with Boyle's law. Boyle's law states that the volume of a given or a fixed mass of gas is inversely proportional to its pressure, provided that temperature remains constant. Now, in order to write this mathematically, what it means is that V, which is volume, is inversely proportional to pressure. And if we extend this, what it will mean is that V is equal to K over P, where K is the mathematical constant. Solving for K, we will have this to be PV is equal to K. Now, since we say that V is inversely proportional to P, what it means is that as the volume is increasing, pressure will be reducing. Or as the pressure is increasing, volume will be reducing. In order for us to understand how these changes will go, we will have to get this to be P1V1 is equal to P2V2, so that we'll be able to see if pressure is actually increasing, what will happen to volume. And in this mathematical expression, P1 here stands for the initial pressure, and V1 is the initial volume. P2 here stands for the final pressure, and V2 here stands for the final volume. Now, in order to understand experimentally how this Boyle's law or what the interpretation means, we will have to use an illustration like a syringe. If a syringe contains some gas bubbles, and the syringe has a volume, assuming that we are using a 5 ml syringe, now if you push the plunger inside, as the plunger moves inside, the volume that the gas occupies will actually reduce. If that volume is reducing, or if it has reduced, you will find out that the pressure, the gases will be locked in a smaller confinement than originally what the volume was. And if they are locked in a smaller confinement, or the volume has reduced, what it will mean is that the gases will tend to collide more with each other and with the walls of the container, thereby increasing the pressure of the gas. Now, in order for us to solve a real-time example, we will take this question. The question here says that a gas occupies 200 centimeter cube at 100 kilopascals. What will be its volume if the pressure is increased to 250 kilopascals? Now, this is Boyle's law. And we have said that P1V1 is equal to P2V2, where P1 is initial pressure, V1 is initial volume, P2 is a final pressure, and the V2 is the final volume. Now, if we look at the question, we will be able to see that the gas occupied 200 centimeter cube. This happens to be the initial volume. So our V1 here is 200 cm cube. And this gas occupies this volume at 100 kilopascal. So our P1 here, which is the initial pressure, is 100 kilopascal. Now, the question is, what will be its volume? This volume now is the final volume, which is V2. what will be this volume if the pressure is increased to what? 250 kilopascal. So that means the P2 here is the final volume, which is 250 kilopascal. So if we extend this formula that we've written here and solve for V2, if we make V2 the subject of formula, then it will be V2 is equal to P1 V1 all over P2. Our P1 is 100 and our V1 is 200, all divided by our P2, which is 250. If we multiply this, we will get what? 20000, which is 20,000 all over 250. And if this 0 cancels this 0, we will have 2,000 divided by 25. And if we solve this, we'll be able to get 80 cm cube. Always remember that after solving, you must make sure that you include the units. Now, going back to what Boyle's law says, that volume is inversely proportional to pressure, and that if volume is increasing, pressure will be reducing. If pressure is increasing, volume will be reducing. Now, we are able to see from our question that pressure increased from 100 to 250. Thereby, volume is supposed to increase. So, volume reduced from 200 cm cube to 80 cm cube. Now, with this, we'll move to Charles' law. Charles' law, we say that Charles' law states that the volume of a fixed mass of gas or a given mass of gas is directly proportional to its absolute temperature, provided that the pressure remains constant. If we say that volume is directly proportional, recall what I say, absolute temperature. And absolute temperature is temperature in what? Kelvin. So if volume is directly proportional to temperature, what it means is that as volume is increasing, temperature will be increasing. Now, mathematically, if we break this down, it will be equal to V is equal to KT. And if we solve for K here, we will get V over T is equal to what? K. Now, since we say that if volume is increasing, temperature will be increasing, how then can we understand this? Then what it implies is that if we want to see how it goes, we'll extend this to what? V1 over T1 is equal to V2 over T2. With this expression, we can be able to solve and see how volume increases and temperature increases. And from this expression, V1 here implies or means initial volume, and temperature T1 here means the initial temperature. Then V2 here means the final volume, and T2 here means the final temperature. Now we will solve a real-time example. We will look at the question. The question says that at 17 degrees Celsius, a sample of hydrogen gas occupies 125 cm cube. Full stop. What will be the volume at 100 degrees centigrade if the pressure remains constant? Now, if we will solve for this, we will be able to use the formula V1 over T1 is equal to V2 over T2. And we know that V1 here is the initial volume and T1 is the initial temperature, whereas V2 is the final volume and T2 is the final temperature. Then if we pick these variables from the question, V1 here we were given that at 17 degrees Celsius, a sample of hydrogen gas occupies 125 cm cube. So the volume, initial volume here is 125 cm cube. And it says at 17 degrees. So this 17 degrees is our T1. But to remember that when we defined Charles' law, we said at absolute temperature. And absolute temperature is temperature in what? Kelvin. So our temperature here is given as 17 degrees Celsius. And for us to convert it to Kelvin, we'll have to add what? 273. So if we add this, we will get what? 290 Kelvin. Now, we have been able to get our V1 and our T1. So we look for V2 and T2. Now, again, the question says, what will be the volume? That means we are looking for what? Volume at 100 degrees Celsius. So our T2 is given as 100 degrees Celsius. To convert to Kelvin, we'll add 273, so that this will be 373 Kelvin. Going by our formula that V1 over T1 is equal to V2 over T2. Now we've been able to get our variables and we are looking for V2. That means we make V2 the subject of formula. V2 is equal to what? V1 T2 all over T1. And if we fix this, our V1 happens to be 125 times by our T2, which is 373, all divided by our T1, which is 290. If we solve for this, we will get 161 cm cube. That is our final volume. Now we say that in Charles' law that as the volume is increasing, the temperature will be increasing. Now, and if we look at the question here, temperature increased from 17 to 100, and our volume increased from 125 cm cube to 161 cm cube. Then lastly, we will solve the general gas law, the formula. And if we look at our Boyle's law and our Charles' law, our Boyle's law says that PV is equal to K, and our Charles' law says that V over T is equal to K. Now, if we combine these two formulas, we will be able to get what? PV over T is equal to what? K. And if we extend it to see how changes in volume relates to changes in temperature and pressure, we will be able to establish this as P1 V1 over T1 is equal to what? P2 V2 over T2. Now here, the P1 stands for initial pressure, and V1 stands for initial volume, T1 stands for initial temperature, and this one, P2 V2 T2, stands for final temperature, volume, and pressure. Now we take a real-time example. The example says that at STP means standard temperature and pressure, a certain mass of gas occupies a volume of 790 cm cube. Find the temperature at which the gas occupies 1000 cm cube and has a pressure of 726 millimeter mercury. Now, in order for us to be able to solve this, we have our formula P1 V1 over T1 is equal to P2 V2 over T2. And we've been able to establish what these variables means. Now, going from our question, we'll be able to pick individually what these things are T1, V2, P2, and our T2. Now, from our question, the question say at standard temperature and the pressure. So this standard temperature and pressure gives us our P1 and our T1. The standard pressure is 760 millimeter mercury. And the standard temperature is 273 Kelvin. Now, they say at STP, a certain mass of gas occupies a volume of 790. That is our initial volume, V1, which is 790 cm cube. Now, we are told to find the temperature at which the gas occupies 1000 cm cube. Find the temperature. So, T2 is actually what we are looking for, which the gas occupies 1000 cm cube. That means the V2 here is 1000 cm cube, which is our final volume and has a pressure of 726 millimeter mercury. So our final pressure as well is 726 millimeter mercury. Now, if we have P1 V1 over T1 is equal to P2 V2 over T2, and we are looking for T2, if we make T2 the subject of formula, we'll have T2 is equal to P2 V2 T1 all over P1 V1. And this is equal to our P2 here. Our P2 is 726 multiplied by our V2, which is 1000, multiplied by our T1. Our T1 here is 273 Kelvin, all divided by our P1 V1. Our P1 here is 760 millimeter mercury, multiplied by our V1, which is 790 cm cube. If we solve for this, we will be able to get 330.1 Kelvin. Don't forget that the unit is very, very important. If you solve this and you fail to put the unit, then you may not be able to get the final answer. You may get the workings without getting the final answer. Now, we made expressions of Boyle's law and Charles' law. And we say that in the illustration of Boyle's law, that is like getting a syringe that already has some gas trapped inside it. And when you push the plunger in, which reduces the volume, the gas will tend to interact more, which will increase the pressure. Then in the Charles' law, the illustration can be given by a balloon, which has already an inflated balloon, and which is dropped on top of hot water. The hot water already makes it that the temperature has increased. If the temperature is increased, the implication is that the gases in the inflated balloon will tend to acquire more energy from the heat coming from the water. And if they acquire more energy, they will tend to do what? Collide more with each other and with the walls of the container, thereby increasing the volume of the balloon. That is already telling us that what? As the pressure is increasing, what will happen? The temperature. As the volume is increasing, the temperature is increasing. So this is a proper illustration of Charles' law. I believe this must have been able to, explain in depth while breaking the things down for our students at WAEC and JAMB level, and as well undergraduate students who are doing sciences at their preliminary year, which is 100 level, and even levels beyond that. So if you have enjoyed our video, it will be good that you subscribe so that when next we'll add a video, you will be notified. And as well, if you've enjoyed what we've discussed today, and there are areas that you don't understand clearly, it will be good that you drop your question in the comment section. Then if you have a friend who as well you think that this video may help, it will be good that you share it with the person. And don't forget to like our video and subscribe. Thank you for watching. In our next video, we will discuss the extension of these gas laws, where we'll talk about the Avogadro's law, we'll talk about the Lusak's law, and we'll talk about Dalton's law of partial pressure, and we'll talk about, lastly, on the Graham's law of diffusion. Thank you for listening.